Good day once again, everybody, and we are back together. So we are looking at question 3 from this IEB 2024 exam. As we are preparing for your chemistry exam, let's get right into it. So please, if you haven't subscribed, just click on that subscribe button, and I promise you we'll keep giving you even more and more of this great content. So let's get right into it. So they say to us, we've got the reaction of magnesium carbonate tablets with hydrochloric acid was used to investigate the effect of different factors of the rates of reaction. In each experiment, the mass of the tablet was the same and equal volumes of acid were used. That's very important, right? So they kept the mass the same and they used equal volumes. Okay, so we know about controlled variables, so that is what they are actually telling us. So they're saying to us, write down a chemical equation for the reaction between magnesium carbonate and hydrochloric acid. Now, very important. So magnesium carbonate would look like this, and hydrochloric acid like that. Okay, and we know that once they react with one another, they will form, in fact, just for space, let me just write it right at the end. Okay, plus hydrochloric acid. That would give us, now this is a carbonate base. Okay, so that means that we are going to get a salt, water, but we're also going to get carbon dioxide. So we're going to get magnesium chloride, which is our salt. We're going to get H2O, and we're going to get CO2. All right, now we just need to make sure that we balance out the equation. We've got 1 hydrogen, we've got 2 on the other side, so we need to make sure we've got 2 on this side. What else are we missing? Yeah, it looks like we are done. Okay, right, so that is how we're going to balance out that reaction. So they say describe an appropriate experiment method to measure the rate of this reaction. Include the appropriate measuring equipment and all quantities that should be measured to determine the rate of reaction. Okay. So there are several ways. I think you can use a measuring scale for magnesium carbonate. Okay, so use a scale. Okay, scale balance. All right, to measure the mass. Okay, of the contents and container. All right. So what you would notice is that as the mass, as the reaction continues, the mass of the container and its contents will keep decreasing because of that magnesium carbonate being used to form carbon dioxide. That's one of the ways. I suppose you could also, because this is an acid-base reaction, you can also use some kind of a pH scale, maybe, just to show some indicator that you can use. I think that's one of the ways in which you can do it, but let me stick to this so that we don't take unnecessary time. Right, now the next question says, the result of 5 experiments are tabulated. Okay, so there it is. They say, can the results of experiment 2 and 4 be meaningfully compared? Answer yes or no. So we're comparing 2 with 4. So let's see, concentrations are different. But can you see this? Temperatures are also different, right? So now the answer is no. And the reason for that is that there's more than one independent variable Okay. Therefore, it will be difficult to determine which variable to determine the variable that is responsible. Okay, so for the increase or decrease in the rate of the reaction, right? For the change rather in the rate of reaction. You can continue writing that down. You get that, ladies and gents. So for a fair test, you always need to have only one independent variable. There must only be one thing that you are changing in your independent, in your reaction, right, in your comparison, so that you can tell which one has the effect on the rate of reaction. Now they say to us, what conclusion can be reached when experiment 4 is compared to experiment 5? Okay, so let's check. Firstly, is it a fair test? Yes, it is, because concentrations are the same. The only thing that is changed is the initial temperature, right? So you'll notice that we want to compare what conclusion can be reached when experiment 4 is compared to experiment 5. Okay, so experiment 4 will have a higher reaction rate, or we can say, okay, so experiment 4 have a higher rate, okay, compared to reaction 5 or experiment 5. Okay, they didn't ask us to compare to explain, all right? They only asked us to determine which is what will happen to the reaction rate, or what conclusion can be made, okay? Right, so 3.4, right. So they said to us, compare experiment 1 with experiment 2, explain the results with reference to the collision theory. Right, so definitely here now we need to actually write down which one or what is the cause of the change. Okay, so when you look at experiment 1 and experiment 2, right, what we are doing there, okay, so firstly, initially the temperature is the same. The initial temperature, the concentrations are the same, right? And in this case, they say the whole time of reaction to the end, whole tablet, right? So what they did is that in experiment 1, they used the whole tablet, and in experiment 2, they used a crushed tablet. Okay, so an increase, all right, in the, okay, or we can say that experiment 2 uses a crushed tablet, which will increase so we'll have a higher surface area, right? Surface area, and so that will increase the number of collisions per second that are taking place, and that will increase the collisions per unit time. And that will result in a higher rate of reaction. That will increase rate of reaction. Okay, right. You can also just simply say an increase in the crushed tablet results in an increase in the state of division, okay, of the tablet, and that will increase the number of collisions per unit time, and that will increase the number of effective collisions per second. Okay, right, let's go on to the next one very quickly. Right, they say define activation energy. Remember, by definition, this is the minimum energy required for a chemical reaction to take place, right? Please, you'll write that down. So just remember minimum energy required. Okay. Right, you can complete that. They say, what does the shaded area of the graph indicate? Okay, sorry, I forgot to mention or to read the statement there. They say the graph below shows the Maxwell-Boltzmann distribution curve for the reaction mixture in experiment 1. The activated energy for the reaction EA is marked. Okay, right, so in this case, here they've given us the Maxwell-Boltzmann distribution curve. And so they say in 3.6.2, what does the shaded area of the graph indicate? So remember, it shows us the number of particles that have sufficient kinetic energy, right? It means these are the particles that have the kinetic energy greater than the activation energy. Okay, so we can say these are the number of particles with kinetic energy EK greater than EA, and therefore can undergo have sufficient kinetic energy, right? Okay, so they say on the graph above, draw a new distribution curve for the reaction mixture in experiment 3. Label the curve as experiment 3. Right, so experiment 3, let's see what happened in experiment 3 in comparison to 1. Right, now when you note in experiment 3, what happened is we had a graph, we had a concentration of one of our reactants being higher, right? And everything else kind of remains the same. Okay, they used whole tablet here, they used whole tablet there. All right, so what's going to happen in this case is that also we're going to start at 3. Now remember, in this case, this will result in a higher peak than the previous graph. And the only reason for that is that now, remember, the average kinetic energy is the same because temperature is exactly the same. But because we've got a higher concentration of one of the reactants, that's why we have now a more number of particles that are present in that case. Okay. Right, and then, well, that's it. Oh, they said we should label, so we must just label this as experiment 3. Well, ladies and gents, that's how the cookie crumbles. That would have earned us the number of marks, 20 to be precise. So please, let's look out for those free marks as we are going to delve into question 4. I'll see you guys next time. Sharp, sharp.